So then, Joe, we're in that wonderful position where the customer behind us has decided to have an electrical vehicle and they're going to have the Zappi EV charging point installed. However, it's really crucial that before the installation occurs that we do the pre-installation site survey. What sort of information are we going to be required for that survey?
Well, we're introducing quite a heavy new load onto the existing system, so we want to make sure that the system is capable of dealing with that. It'd be much the same if we were looking at installing, say, a new electric shower.
Yeah.
However, there's some key points that we also need to look at that relate directly to the fact that we're installing an EV charge point. So we're going to look at the regular things. We're going to look at the cable route, and we're going to look at the existing equipment. We're going to have a look at the old consumer unit and see what spare ways there are, what RCD protection there is, that kind of thing. But there's some critical information that we need for this as well. And some of this information will need to be transmitted possibly to the DNO.
Oh, yeah.
So this is quite a big deal. So the place where we're going to find an awful lot of that information is round at the origin. So I think we're going to have a look at that now.
Let's have a look. So we'll move round to the intake position of this installation, Joe, and there's some information we're going to need to gather here as part of our site survey, as well as informing the DNO. Can we get away when we're installing an EV charging point with not letting our local DNO know, Joe?
The simple answer is no, you can't. If you're installing an EV charge point, you must let the DNO know. And the reason for that is obvious. There's going to be more and more properties over the coming years getting EV charge points installed. There's going to be a bigger demand placed on the existing infrastructure, which we're pretty confident can handle it. We're not worried about that. But really, it's part of your social responsibility to help the DNO, the electricity suppliers, know where there's going to be greater demand and where there's going to be peaks in demand. So it's very important that we take our social responsibility on board and let the DNO know if we're installing it.
Demand being the word there. So the maximum demand and diversity of this installation is the critical point.
Yeah.
As soon as we exceed 60 amps with our calculation, we must inform them prior to actually installing the EV charging point, Joe. If we find that that maximum demand and diversity calculation is under 60 amps, and we've done a few, Joe, how easy is it to keep them under 60 amps?
It's almost impossible. In fairness, this property is not an electrically hungry property. We've got gas central heating and hot water. There's no electric shower, there's no electric hob. So you can imagine it's not a very power hungry property. However, when we start doing the calculations and we think about installing our EV charge point, we very quickly go above that 60 amp up to somewhere around 70.
Okay, so that means we must inform them before installing it.
Absolutely.
If you're in a fortunate position where your maximum demand calculation becomes under 60 amps, you've got 28 days after install in order to notify your DNO.
Absolutely.
However, Amendment 1 to BS 7671 introduces an important change to the maximum demand and diversity calculation. If the EV charge point includes a load curtailment device that can be set to limit the maximum demand on the property, then this can be taken into account when doing your maximum demand and diversity calculation. This means a device that measures the total current flowing into the property, and if this total current goes above 60 amps, the power going to the electric vehicle is automatically reduced. The MyEnergy Zappi includes this device, so as long as the maximum demand you calculate for the property is below 60 amps before the Zappi is installed, there's no need to get approval from the DNO before you do the installation. Of course, you've also got to make sure that this limit device is set correctly when you do the installation, and you should also contact the DNO if you have any doubts about the authorised supply capacity. Let's go back and have a look at the supply cable coming into this property.
So we're looking at the information that we've got in here. So as an electrician, we're coming to this point here, and I noticed that the supply cable coming in from the supply authorities is coming underground into the bottom of our cutout.
Yeah.
Okay. Any issues with other ways the cable could come in, Joe?
Yeah, in sort of certain towns and certain rural properties, maybe we've got a row of houses.
Yeah.
It was common practice to bring one cable, bring it to the first property, and then to loop from there to the next property, and so on and so forth. And of course, all the properties would have their own meters and their own electrical installations. However, again, let's think through the situation. Every house on that row gets an EV charge point and plugs their cars in. You're going to very quickly start overloading that first cable that comes to the first property, and even possibly several of the subsequent cables. So if we come across a property where we think we've got a looped supply, what do we need to do, guys?
Stop. You've got to let your DNO know, and you can't at that stage install your EV charging point. There'll be some other stuff that needs to go on in the background before you're given permission to install an EV charging point. So that's really crucial and really critical. We haven't got that issue here, Joe. Supply cable comes into the bottom. We notice it's got a PME sticker here. We know it's a TNCS earthing arrangement. Does that throw up any issues for us?
Well, we're installing a Zappi charger, so we can sit back and relax with a TNCS system. But it's very much worth thinking about this fact that even if you come across a TNS system and you're installing an EV charge point, you still have to treat it as though it were TNCS, because you can only treat it as a TNS system if you can guarantee that that system will never be converted into a TNCS system at some point in the future. How are you going to guarantee that it'll never become TNCS,
Just rub
Gaz?
that magic ball, hope for some information to come back. You can't. So, of course, you're going to have to presume that would also be a TNCS earthing arrangement.
Absolutely.
But we're installing a Zappi EV charging point.
Yep.
It doesn't matter for us, does it?
No,
It's
electrode.
no, and it's the information that's required for our paperwork and obviously for the DNO.
Yeah.
We come into a 100 amp cutout fuse. Can we presume that's a 100 amp cutout fuse, Joe?
We can assume it is indeed a 100 amp cutout fuse, but again, we come back to that 60 amp value. We can't assume it's 100 amps for maximum demand purposes.
Okay.
So obviously we'd want to make sure that we treated the tail situation, the cable coming out of here, as though it's a 100 amp fuse. But from a demand point of view, we want to think about it as being a 60 amp fuse, because that really is what the DNO originally intended to allow for properties as a maximum demand value.
Hence, once you go over 60 amps, you'll notify them before the install to the DNO. That makes logical sense as well. We've got the usual arrangement. We've got a 25mm squared double insulated meter tails, our 16mm squared earthing conductor, and it may be a case, Joe, that when we go in and look at the install, actually we're going to have to install another consumer unit in there.
Possibly.
So we might have to break into the tails, maybe put some Henley blocks in there. Can you talk us through the safety procedure for that as well, please?
Well, obviously, we don't want to go pulling the fuse if we can possibly avoid it, because that really is the property of the DNO. In this situation, we're quite fortunate because we've actually got an isolating switch within the meter that we can use to isolate the tails. However, if you come across a situation where you don't have that, and there's a lot of them about, you need to inform the DNO and they will come out and install a double pole switch for you. So they'll actually come out and put that in so that you can then safely isolate the installation, split the tails if you need to, don't get prosecuted for pulling the fuse, and don't get prosecuted for electrocuting someone by doing the terrible risk of working live. So that's just an important little point to think about.
I think now we swing around and look at the consumer unit. Let's make some other judgment calls based on the installation that we've already got, Joe.
Let's go.
So we stepped inside and to look at the consumer unit now as part of the site survey. Standard arrangement, main double pole switch and several circuits here. We've got two blank ways, and then we've got a split board. We've got an AC 30 milliamp RCD protecting several circuits within the house. And we've also got a blank on the RCD side as well. So it looks as if we've covered all bases, Joe. So okay to go on one of those for the circuit?
Well, let's kind of work from left to right. Here are options. We could install it into the spare way that we've got here. However, we've got to think about the RCD requirement for our EV charge point. We need to have RCD protection because obviously we've got a socket outdoors kind of situation, so we need to have RCD protection for that. We may need RCD protection for the supply cable going from the consumer unit out to the charge point. So let's just work through that logically now. The Zappi charger has RCD technology built into the charge point.
It does.
So the fact that it's built into the charge point, Gary, what potential problem could start to happen if we've got this RCD protecting the RCD that is in our Zappi charge point?
Well, a couple of things there. First of all, selectivity. So you're going to have two RCDs rated at 30 milliamps, and there's no guarantee which one will operate, and that can cause inconvenience. So we've got a problem with selectivity. We also said this is an AC type of RCD, and we know that introducing EV charging points can cause issues with a current which is DC appearing in the line and neutral conductor, and that can confuse AC RCD. So there's two issues there: lack of selectivity and a chance of confusing or stunning an AC RCD. So it's not deemed good practice that we install our EV charging point off from this point here, Joe. That means I've got another two options. I've got two options here. Can I use one of those, Joe?
Well, we've got our non-RCD protected side there, so potentially, again, we could use that. Now, the thing we've got to get around here now is we've got to think, how are we going to install our cable without RCD protection? We've got the RCD protection in the Zappi protecting the socket outlet, but we don't have RCD protection protecting the cable. So let's try and think about how do we install the cable without an RCD requirement. So what would be our options for that?
So we're requiring to maybe surface clip twin and CPC cable would remove the need for the RCD, or we install it in an earth metallic sheath, possibly steel or armoured, in order to feed the charging point itself. Both of those instances would remove the need for an RCD.
So for the purposes of this installation and this instructional video, Gary, how are we going to go about wiring up our Zappi 2 charger?
We're not going to come off the non-RCD side of the consumer unit. By the time I'd sourced the appropriate size Hager breaker, it might have been easier to install an additional consumer unit. For the purposes of this presentation, I want to show you how to install a additional consumer unit, the towels, the Henley blocks, etc. Also gives us an opportunity if we want to introduce surge protection into the new consumer unit. So that's the consumer unit looked at. Now we need to verify and confirm the bonding to gas and water in this installation are in place. I'm going to nip out and look for the water.
I'm going to go and find the gas. That was pretty easy. So Gary, I had the monumental task of finding the gas bond. There it is.
Yeah.
Okay, so I've seen this green and yellow conductor coming onto this bonding clamp, coming onto this gas pipe. Have I therefore verified the gas bond connection?
You found the gas bond connection. We verify it through measurement, Joe. We're going to need to measure the resistance at this point here, and I always like to measure the resistance actually onto the pipe itself in order to verify it. I've been under the sink. I found the water bond as well. I've only found it. We also need to measure it to verify it's in position.
That's very important we do that.
So I've had the pleasure of coming inside, Joe, just to warm up a little bit. It's been cold today.
Absolutely, and the customer has very kindly allowed us the use of their dining room table in order to do the next stage of this, which is the all-important maximum demand and diversity calculations. So let's get stuck into that.
So we're going to be using the maximum demand and diversity from Appendix H of the on-site guide in association with this document here, Joe. What book's this?
So this is the Electrical Installation Design Guide published by the IET.
Okay.
A really, really excellent book for if you're doing anything to do with electrical calculations. I think that's a must-have. It's really, really helpful.
There's some different examples in here. We're actually going to be using example 2 in order to work out the maximum demand of this installation.
Absolutely. Now, maximum demand is one of those things, isn't it, where it's down to your engineering judgment. There's lots of different ways we could calculate it. Every installation will actually be slightly different in terms of maximum demand. And it's one of those things where you need to make a call on what method you're going to use, what you think the maximum demand will be. But in this case, we think that this is appropriate for this kind of installation, this kind of property. We think that the information in the on-site guide and inside this book are both really, really appropriate.
With that in mind, we've got to start off by first of all identifying the sizes of circuit breakers in circuit, Joe.
Fantastic.
So let's do that. Let's just move this to one side so you can probably get this a little bit clearer into view. So we've got now with our consumer with an added circuit, we've got a 32 amp overcurrent protection device for the EV charging point, Joe.
Right, so we've got the new circuit, which is a 32 amp EV charging point. That's great.
We've got 2 ring final circuits fused at 32 amp as well, probably upstairs and downstairs, Joe.
Yeah, so we've got a 32 amp socket circuit. Okay, and we've got another 32 amp feeding sockets as well.
Okay. We've got a 16 amp device feeding the cooker circuit. We talked about it earlier. It's just a fan assisted cooker. There is no electric hob or anything else.
Okay, hence it's a slightly smaller breaker than we might normally come across. Yep.
Yeah, we've got that, and we've now got 3 6 amp devices. One of those devices is actually for the smoke detector circuit, Joe.
Okay, so we've got 6 amp smoke.
Yeah, I think later on we'll probably put that down as not applicable. The current being drawn by one smoke detector circuit.
It's hardly going to draw anything at all, is it?
And 2 lighting circuits also fused at 6 amp. I'd imagine it's upstairs and downstairs.
Okay, so we've got 6 amp, we'll call that lights. Let's go lights down. And then we've got 6 amps for lights up. Okay.
So the method we're going to use, Joe, requires us to pick the circuit that we believe to be the maximum demand or the highest demanded circuit out of these and call that 100% of the actual load.
Okay.
So we could choose any of the 3 32 amp devices. However,
well, for my money, when are these ever going to be fully loaded at 32 amps? There's a small possibility maybe for a fraction of a period in the kitchen, maybe, whatever that's on, if you've got a couple of 3 appliances on. However, for my money, it's got to be the EV circuit. Now, we know that the Zappi is very clever and it can manage the amount of current that it allows to flow through to your vehicle. However, there will be times when that is the maximum amount that's being drawn. So I think I agree. We'll call that the 100% largest circuit. Yeah?
We could delve in a little deeper. We could actually do the 7 kilowatts divided by 230 to get the actual current being drawn by it and call that the 100%. But it's a fraction over 30 amps, Joe. I don't see any reason to do that. I think if we call it the 32 amps of the breaker size and call that one 100%, that's our starting point.
Absolutely.
It means now that we can take 40% of the remainder. I think we make the smoke detector not applicable.
Okay.
We do not need, Joe, to apply any further diversity calculations to the cooker. However, we could, if it was a full electric cooker with electric hob, we could follow the guidance in Appendix H to work out the actual demand of that. We don't need to, so again, we've got the 16 amps there. I think we can apply a maximum demand and diversity calculation to the lighting circuits, Joe, by working out how many lighting points we have in the installation.
Okay.
Each of those lighting points will be classed as how many watts?
So each lighting point will be 100 watts.
It will be. And if we add those up, the number of 100 watts and divide it by the supply voltage, we can actually get the current that these circuits could draw. So lighting circuits downstairs.
I've been around and had a little count up.
Okay.
And I've found that there's 11 lighting points down here. So that includes the outside light at the front door that we always miss. So that's 11 light fittings at 100 watts now. We know you can no longer buy 100 watt incandescent lamps, and so that might be a bit of a throwback. But you also never know what kind of fitting someone's going to put up. They might put up a light fitting with multiple lamp holders on there, which could easily actually come to 100 watts. So I think that's not an unreasonable figure to be using.
And the upstairs lighting circuit also, we're going to do the same. So we're going to have to work out how many points. Did you have a look round upstairs?
I've been round, yeah. I had 6 light fittings up there. And again, each one of those will be at 100 watts.
So if we now work out the actual current being demanded from these 2 circuits, we can actually use that figure as part of the calculation to find the 40% from.
Perfect. So here we have got 11 times 100 is obviously going to give us 1,100. And then we can take that 1,100 and divide that by 230. So essentially what we've done there is power divided by the voltage, which we know gives us the current. So we're going to see there that that's going to come out at...
So if we take out the phone, let's look for the calculator on the phone. So that might be a little bit harder than one would expect for me to find. So there we go. If we then simply just do, we've got 1100 divided by 230, Joe. You should see we've got 4.78 amps.
All right, okay, so we'll say that is 4 point... Yeah, we'll go to 2 decimal places, 4.78 amperes.
Okay, and then we do 600
divided
by 230. We've got 2.61, I would go for that.
Coming out at 2.61. Okay, so that's based on that being 600 watts, and then we do 600 divided by 230, which gives us ultimately 2.61 amperes.
So what it allows us now to do, Joe, is actually add up the 32, the 32, the 16. We're going to have a non-applicable here, so we go from that 16 not to 6 now, because we've worked out the demand to be 4.78, and we're going to add that to the 2.61, and then find 40% of that number.
And add it onto
the 100% of the EV charging point.
And that should give us our total
maximum demand
for this installation. Cool. So on camera, we're not going to risk doing this in our heads. So do you want to grab the calculator and we'll add those values up?
Okay, so here we go, back into the calculator. So if we start off, we're going for the 32. Start 32 plus 32 plus 16 plus, we're ignoring the first 6. So we're coming down here to 4.78, agreed? Plus 2.61. Okay, so there we go. That gives us a total of 87.39.
Absolutely.
But we only need 40% of that.
So we're going to divide that by 100.
Okay,
that will give us 1%.
Divided by 100 for 1%.
And then we're going to times that by 40 to give us the 40% value.
And we've got 34.956 amps.
Okay, now if we take that number and add that onto the 100% value, so we've got 32 amps plus 34.956.
Plus 32, we've got 66.956 amps. Which takes us over the 60 amps, and we said that earlier on in the presentation that we find it very difficult to keep this number below 60 amps.
Doesn't change the fact we have to notify the DNO
that's right.
about the installation of an EV charge point, but what it does change is it means that we need to notify them in advance of the installation rather than retrospectively.
Okay.
Now, with those changes that we mentioned earlier in the video that were brought about in Amendment 1 of BS 7671, it's now possible to consider a load curtailment device when you do the maximum demand and diversity calculation. The good news is that the Zappi includes just such a device, and in our example calculation, we can start by doing that calculation without the 32 amps from the EV charger. So our maximum demand would have only been 34.96 amps. With the Zappi charging an EV and the load limit set to 60 amps, that's the most that will be ever drawn from the supply. Now this is important for 3 reasons. The first is that we can proceed with the installation without having to notify the DNO beforehand. The second is that when we fill in the DNO registration form, we need to put 60 amps in as the maximum demand of the premises. And thirdly, we need to tick the box that says, does the premises include an import or load limiting device? We've just established, Gary, that we need to contact the DNO. We've spoken about contacting the DNO on various occasions throughout the course of this video. How do we go about doing that?
We need to Google search for ENA, look for the application form for new EV charging points, Joe.
Absolutely. So the easiest way to do that is just to go to Google, type in ENA, which is the Energy Networks Association, and then type in EV notification. So if we do that, and you can see there that it's already coming up because I've searched for this before, ENA EV notification, and then the top hit there takes us to the place where we need to be. So you can see here we're on the Energy Networks Association website, which is energynetworks.org, and it's a lot easier just to Google that rather than poking around on this website for a while. So we'll just zoom in a little bit here so we can see more clearly what we're looking at. Now, you might get a little bit confused at this point because the page also talks about heat pumps. That's because there is one form for filling in when you're notifying of installation of electric vehicles and heat pumps. Obviously, we can just ignore the heat pump part. But if we just scroll down this page until we're about halfway down, you can see this paragraph: an associated application form for heat pumps and electric vehicles, which must be completed and sent to the DNO, has been created to support the aforementioned process. And the form can be found here. So if we just click on that link, and that will bring up this document, which we'll open up now. So here's the document that we downloaded, and if we just zoom in again on that, you can see this is actually a very, very easy form to fill in. We've got various things here that we need to consider. About halfway down the front page, again, we find the information regarding the maximum demand being above 60 amps or less than 60 amps, and some timescales for us to work to on that one. And then it's just a matter of inserting the information that's required, the installer contact details, the customer contact details, and where the EV charge point is being installed. And then we've got the installation details itself, which is what we've been looking at in part of this video. So what sort of things we'll be filling in here, Gary?
Exactly the information that we discussed previously in the video presentation. So we'll obviously tick the EV charging point, single phase installation, the voltage. There's a section in there to record your maximum demand value in amps, as well as further down the form you can see that we're going to have to highlight the earthing arrangement with the installation.
Absolutely. So we can get that filled in once we've completed our pre-installation site survey, and that shouldn't be too difficult to complete. As you go onto the second page of this, you'll start to see that there's some information now regarding heat pumps. We can just ignore that part, and then at the bottom we just need to sign and date there. So if we've gathered all the information that we need on our pre-installation survey, much of which we've covered over the course of this video, then this should be easy to fill in and then send it off to your local DNO. So Gary, we've looked at an awful lot of information regarding our pre-installation survey in this video, and we're just going to now summarise some of those key points to take away with us. So if you were going to go and install an EV charge point, what would be the first thing that you'd do?
First thing I'd do is download the ENA document. This document almost walks you through your pre-site survey. I'd then go and look at the type of supply I've got. What sort of things would I be looking for?
So you'd be thinking about the type of earthing arrangement that are in place, whether it's a TNS, TNCS, etc. But you'd also be looking very carefully about how that cable gets to the property where you're installing your EV charge point. Is it looped off the neighbour's property, or does it come directly from the main supply?
Because we know if it's a loop supply, that at that point we've got to stop and we've got to contact our DNO, because we cannot install an EV charging point without some other work going on. We'd also be looking at the condition of the service head. We'd be looking at the size of the tails. Is there means of isolation for those tails? And the size of the earthing conductor as well. So standard sort of practice when changing a consumer unit in an installation would be the same sort of things you look at on this part of the survey.
We did want to go around the property and have a look at the existing loads that are in place. For example, is there an electric shower in the property? Is there an electric hob, oven, cooker? All of those sorts of things, because all of that information is going to help us very much with our next stage, Gary, which is to do what?
It leads into the maximum demand and diversity calculation that you have to carry out. And we've seen previously it's very difficult to keep that under 60 amps. And as it goes above 60 amps, you're going to have to contact the DNO before you install the EV charging point. However, you'll still need to contact the DNO if it's under 60 amps within 28 days of the install itself.
Absolutely. However, when we're contacting the DNO and when we're calculating maximum demand, we need to bear in mind those points we brought up earlier in the video about Amendment 1 to BS 7671, now allowing for the use of a load curtailment device when we calculate our maximum demand and diversity. So once we've got all of that done and sorted, we can then start thinking about the actual installation itself. So what's best practice when it comes to installing our cable? Do we want to come off the existing consumer unit if there's spare ways? Well, the most important thing is to consider RCD protection. The RCD in the consumer unit needs to be a Type A RCD, so it's not blinded by any DC current in the EV charging circuit. Of course, you may decide to install a new consumer unit in order to provide more space for the installation, perhaps provide for surge protection and even for future electrical upgrades.
We then want to think very carefully about the installation method of the cable. The reason for that is that it can actually help us to overcome problems with selectivity. If we can avoid installing an RCD or RCBO inside our new consumer unit, then that would be a good thing because there is RCD protection inside the charge point as well. So how would we get around the requirement for RCD protection for the cable rather than the charge point, Gary?
If you can surface clip the cable from the consumer unit to the EV charging point, then the RCD will not be required. However, if it goes within the fabric of the building, you're going to need to further mechanically protect it. The easiest way around that is to install it with a steel wire armoured cable. Both installation methods remove the need for another RCD to be in the new consumer unit that you've installed, as the cable doesn't require RCD protection.
Excellent. So quite a lot of information for us to look at on our pre-installation survey, but by being thorough and making sure that we've hit all of those key points, it's going to help us avoid any problems with our installation of our Zappi EV charge point. Thank you very much for watching this video.